All right, so here we go. So this is looking at our page in Google Classroom on number bases. Some people call these number systems, but for a computer programmer, it's easiest just to think of what base is the number in. And so we're going to start at the top of the page on page 1 of 3, and it says the things that we must know in order to begin. So if we're going to be a programmer and we're going to start, and somebody, maybe us, we need to do something with a number like 126. Notice when you see the number 126, until you know that it's a base 10 number, that does not mean 126. You have got to know that it's in base 10 before you can call it 126. Because as you'll see in just a moment, there is no such thing as 126 in base 2. There's no such thing as 126 in base 7. There's no such thing as 126 in base 16. Did I say base 7? Base 8. Anyway, so when you see the number, you can't do anything until you find out what base that number is in. Now, most computer programmers in the Western world, we assume when we hear 126 that it is a base 10 number. And numbers for people in English are, and I say people who speak English, numbers for us, we look at that, are these numbers English numbers? No. Where do we get numbers from? There's no, by the way, there is no such thing as an English number. It never has existed. Yeah, exactly. And before Arabic, came from Hindi, from India. So the number system originated in India, and then it moved to the Arabs through the Middle Ages. And then out of the Middle Ages, it transferred to the Western world as the Western world extended. And so these numbers, we basically generally just call these numbers Arabic numerals, which for my dad didn't have any education, and my dad had a lot of ignorance. He wasn't stupid. There were a lot of things he didn't know, because he was raised in the Depression. He could go to the 6th grade, and he could go to World War II, and that's about all the education he ever got. And so, but my dad had a lot of prejudice and stuff. And so one day, we were talking, and I said, "Dad, you are really doing a good job of speaking Arabic." "No, I don't speak anything but English." And, "No, Dad, you're doing a good job of speaking Arabic." Because when he would use those numbers, 126, I said, "Those are Arabic numbers." "No, those are English numbers." So, so don't be ignorant like my dad was. And when you say ignorant is not condescending. The word ignorant means what? I mean, you just don't know. Ignorant means you just have no education about that. And ignorant does not mean stupid. Because there are a lot of really smart people like my dad who was just very ignorant about a lot of things. But he was a good guy. Anyway, so the digits 126, we assume, because we're in the English-speaking Western world, that's base 10, and they are in this case. So we need to know what is the number, and then which case are we going to convert that number to? Or do we even need to convert that number to a case? And so when are there times where you would absolutely have to convert a number to some other case than base 10? Well, like if you're going to use time, values of time, and values of time are calculated by milliseconds. So 1,000 milliseconds happen in a computer every 1 second. And so you have to do a lot of conversion with that stuff. All right, so look at the next section here. The next section says, for example, what does 126 mean to a programmer? Well, when you see the numbers 126, you can't just assume that stands for 126. So here we are. we're going to say that that means 126, but that's because we are assuming it to be base 10. And so is there such a thing as 126 in base 10? Yes. Is there such a thing as 126 in base 8? No. It doesn't exist. So unless you know it's base 10, you always have to say the number that you're looking at, you have to say it digit by digit by digit. So 126 is just 126, unless we know it's in base 10. And the proper way to reference this kind of a number is what you see right here, properly referenced. We always will write 126 and with a subscript of 10. Now in Microsoft Word here, if you look up here on the ribbon in Microsoft Word, right up here on the where the fonts are, right in here, if I could get my computer to work up here. Then right here, up on the ribbon, just above that, you'll see X subscript 2, and then right next to it, you'll see where it says X superscript 2. This is the way y'all need to understand what these numbers mean. Because look, if I take my mouse and hover over those two icons up here, if I hover over the first one, it's called a subscript. If I hover over the other one, it's called a superscript. So get used to this. Those are the official names of these things. So if you go to college and you have a professor that talks about subscripts and superscripts, you got to know that simply means sub means it's down below the line, super means that it's up above the line. And so even in Microsoft Word, we see these things being used like this. All right, moving on, we have looked at what 126 means in base 10. Come down, so in base 2, 126 in base 10 is 1111, 1110. So can we call this number right here, can we call this 100? Put a comma right there, put a comma right there. Can we say that 126 in base 10 is 11,111,110 in base 2? No, you cannot say that. Because what is the largest possible number in base 2? 1. That's the largest possible number that you can express. So when you see these stretched together like this, what you have to do is sound them out all the way. So you would say, notice down at C under base 2, properly referenced, what the way that a programmer needs to learn to say this is that 126 base 10 is 1111 1110 base 2. That's the way a programmer needs to talk. Make sense? Okay. If it doesn't make sense, just accept it for now, and the more and more stuff of this you do, the more you'll see it. Okay, look at number 3 here. Base 8, what is 126 in base 10? Now the way we would say this is, what is the octal value of 126 base 10? Octal means 8, or base 8. What do we call this symbol like this? You see that symbol I just drew on the right side of the screen? What is that symbol? What's the name of it? What is it? No. Did you say 10? Did you say 10? No. What? I couldn't hear what you were saying.
I said zeros.
Okay. Some people refer to this as number. Some people call it the symbol for pounds. So LBS for pounds. Some people refer to it as hash or hashtag. But notice what we have here. How many little fingers do we have sticking out? We have 1, 2, 3, 4, 5, 6, 7, 8. And coming from the Latin, 8 is going to be oct something, like octopus. How many tentacles does an octopus have? 8. A healthy octopus has got 8 tentacles. And if I'm around, they've got fewer than that because I like calamari. Okay? So, what's the actual name of this symbol? Do you need to know this? No. Is it ever going to help you make money in life? No. But the real name for that thing is called an octothorpe. Octothorpe. That's the real name of that symbol. It's called octothorpe. And you can remember it because it's got 8 little tentacles out. Okay? So, by the way, what's the word in Spanish for 8? Ocho, okay. And so ocho and oct sounds like there's some sort of a common root, and it's Latin. What is the number 8 in Arabic? Do you know? You don't know? Okay. I don't know either. But I know in the Western world that it comes from 8. Okay, so the way that we would express this, look at 3C, is that we would say as a programmer, we would say 126 base 10 is 176 base 8. That's the way you'd want to say it. Now, do programmers, when they're talking in meetings, do they ever say that 126 is 176 base 8? Yeah, they do. Is it technically correct, though? No, it's not. So you'll never say something like that. You always say 176 base 8. Look at base 16. What is 126 in base 16? The proper way to ask that question is, what is the hex value of 126 base 10? All right, so the equivalent of 126 in base 16 is 7E. Go figure. All of a sudden, we're talking about a number, and we have to use a letter to express the number. And that's because we're in base 16. So let's scroll down for a moment. I'm going to scroll down, and y'all can just turn the page on your computer, on your paper there. Scroll down and to page 3. Okay, so whenever you are, have some more of these if y'all need a copy of it. Look under base 16 and look under the counting values in base 16. At the bottom, we start counting up. To count in base 16, you start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But after we get to 9, what are we going to do for a 10? 10 is expressed with an A. 11 is expressed with a B. 12 is expressed with a C. 13 is a D. 14 is an E. 15 is an F. So, yep.
Will we ever learn ASCII?
Yeah, we're going to talk about ASCII. We're going to talk about ASCII later in the term, but from here, we're definitely going to be plugging binary into ASCII at some point. Okay, so what is the largest possible counting value in base 16? F. Exactly right. So if you wanted to say 16 in base 16, you would simply say F. or 15. Be actually 15, wouldn't it? All right, so let's go. Go.
Would it be possible that there would be, like, one of the specific letter to be capital or lowercase whenever you code it from binary code?
Say that again.
Like, whenever you were typing the binary code on a computer, would it be saying an error or something if you do capitalization or not on the lowercase
No.
letter?
So you're asking about, is A, B, C, D, E, F capitalized or not? In base 16 it does not matter. But by the way, it does matter in base 64. And base 64 is used by computer science. And it's mostly used for encryption of things. And so there, and capital A and the lowercase a means two very different things. Yes, sir. I'm sorry? Oh, okay. Well, for those recording, let's ignore it, okay? Yeah. All right, so go back up, though, to the top up here. So look at bottom of page 1, things to remember about bases. When we say the name of the base, like base 2 or base 8, when you say the name, you are telling us right then how many counting values there are for that base. So like base 8, there are 8 counting values. But the largest possible counting value is always going to be one less than the name of the base. So in base 8, your number of counting values is 8. But the largest one is going to be a 7. And how can that be? Why do we have to be aware of this? Because computers start counting with 0. So if I'm going to count in base 8, I'm going to start 0, 1, 2, 3, 4, 5, 6, 7. I can't go any higher than 7 in base 8. So in base 8, you're never ever going to see a result where that, like if you maybe have like a 128, if you saw this, 128 base 7, you know right away that there's a mistake. Because it's impossible to have an 8 in base 7. This would be wrong in every possible way. Expect to see something like that on the quiz this week. All right. But how many actual values do I have in my counting list over here? How many counting values are there in that list? 8. There's 1, 2, 3, 4, 5, 6, 7, 8. So when you say the name of the base, this is base 8. When you say the name of the base, you're saying how many counting values there are. But the largest possible counting value is always one less than the name of the base. That's the way the system works. And it works that way in every base. It even works that way in base 10. So look at base 10 right here. Base 10, how many counting values are there? Remember, when you say the name of the base, you're saying the number of counting values. So how many counting values are there in base 10? Listen to my words. How many counting values are there available to be used in base 10? 10. Whether you call it 10 or 10 or whatever you call it, there's just 10. And they go 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all together, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But the largest one is one less than the name of the base because we always start at 0. In base 10, you can have a number like 10. But the largest counting number is the 9. So what do you see here? If I have a number like this, $9.99. If I add 1 penny to that, what will the value become? If I add plus 1 penny, what would the result be? It would be 10, right? Because what happens? Well, the 9 becomes a 10, but you can only write down the 0. That 1 gets carried over. 9 plus 1 is 10. We put the 0 down, carry the 1. 9 and 1 is 10. We put the 0 down, carry the 1, and there we have the 1. Is that the way y'all learned to count? Do math? Cool. That's the way we learned back in the 50s, all right? But just keep in mind, when you say the name of the base, you're saying the number of counting digits, but the largest possible value is 1 less than that value. I'm looking here to watch our time. I've got it on this computer today. It's 13 minutes. Okay, so look at page 2, and we have a little grid here. And notice on the grid that what we have across the top is all of the exponents beginning with 0. Always start on the right. Yes, ma'am?
I was going to ask about A16, why it shows like 3 as the largest value.
3.
Base 16 on this page.
The largest possible value in base 16 is E.
So where does it show 3?
Where?
Look back on the page. It shows up on
Page 3?
on page 1.
Page 1?
And if you look back at the table for base 16, it shows 3 for the largest value. And then
Ah, thank you. Do you know, I guess if there is an element of dyslexia to me, it is that I always reverse a 3 and an E when I type. Thank you so much. I appreciate that. As my wife will tell you, I make lots of mistakes.
everyone makes mistakes.
We all make mistakes. Okay. All right, so look at the base 10 chart on page 2. And then notice across the top we have all of the exponents. And so beginning on the right side, and we always start on the right and move to the left in trying to calculate these things. So we start with the exponent of 0, and then we have the exponent of 1, and then across the page. Remember, I told you all this yesterday. If you can ever get these first 2 starting values correct, then you can build the rest of these things no matter what it is. If I were to say, build a table for me in base 137, by the way, I am going to do this. I'm going to ask y'all to build me a chart that shows all of the exponents up through 7 for base 72. I'll ask you something like that. So what you'll do is you'll have 72 to the power of 0, 72 to the power of 1, 72 or 71 to the power of 2, 71 to the power of 3. All right, so how are you going to build this table? If you can build the first 2, you can build anything. Because you know that anything to the power of 0 is 1. Doesn't make any difference what it is. Anything to the power of 1 is that number. If you can memorize those 2 things and remember them until the day that you clock out and go to heaven, then you can do any base conversion there is. Those are the first 2 things. Notice in base 10 in the top table, 10 to the power of 0 is 1. 10 to the power of 1 is 10. And from there you just multiply by the base. 10 times 10 times 10 times 10 times 10 times 10 times 10, and so on. That's how you do all this stuff. It makes no difference what base you're talking about. They all work exactly the same. Now, by the way, is this the way that they teach you? I just took a computer science course with the University of Texas, and the way that they teach this stuff there is different. But I promise you, I've been doing this since 1963, and this is the easiest way there is to remember base conversion. I promise this is the easiest way there is. All right, so look at base 2. There you see 2 to the power of 0 is 1, right here at the top. 2 to the power of 1 is 2. Times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. Times 2 is 64. Times 2 is 128. Times 2 is 256. Times 2 is 512. And 512 times 2 would be 1024. And that you just keep going. That's the way they all work, exactly the same. Look at the base 8 chart. Oops. Base 8 chart. 8 to the power of 0 is 8 to the power of 0 is, come on guys, stay with me. 8 to the power of 0 is 1. 8 to the power of 1 is 8 times 8, 64 times 8. If you don't know it off the top of your head, it's right there, 512. And look at the base 16. By the way, tomorrow I'm going to show you how to use Microsoft Windows to figure out a lot of this stuff. But base 16, we start off with 16 to the power of 0 is 1. Because anything to the power of 0 is 1. Every time. All day long, even in daylight counting time. Or standard counting time. It's always going to be 1. By the way, is there such a thing as daylight counting time? No, it's a bad, stupid joke. You know, but it doesn't make any difference. Whether it's daytime or nighttime, whether you're asleep or awake, anything to the power of 0 is 1. Anything to the power of 1 is that number. So 16 to the power of 0 is 1. 16 to the power of 1 is 16. Times 16 is 256. Times 16 is 4096. Times 16 is 6536. And so on, across the board.
I'm sorry, what? 16 to the power of 16?
16 to the power of 16?
Yeah, you were reading that.
Oh, I guess I read it wrong. Okay, let's move on. Oh, I see. Duh, there's another typo. Man, you are deadly on these things.
There's another one.
I am so thankful for proofreaders like you. By the way, who's going to college?
There's another 16 over there.
Oh, where at? Another one over there. My gosh. Okay, you're going to college. Okay, you put this in your pipe and put it in the bank. Just a minute. Is there another one?
Yeah, 8 to the power of 4. There's not 4.096.
No, it's not 4 point. Should be a comma. All right. Okay, going to college. I'm going to tell you something that will make the difference in your whole life. If you go to Harvard University, I guarantee they will force this on you. When you go to college, first thing you need to do is get you a friend who will be your proofreading partner, so that no matter what you type, before you ever turn it in, it goes through your proofreading partner. I learned this the hard way, and I found out that the best proofreading partner for me is my wife, because my wife can spot a misspelled word. But you can tell she didn't proof this for me, did she? But my wife can spot a misspelled word at 50 paces, blindfolded, backwards. She is that good at misspelled words. And so she's merciless to me. And she said, Jimmy, you can't do it this way. And so, anyway, get yourself a proofreading partner. In Harvard, at Harvard, at least they used to, you have proofreading circles of friends. And if your paper that you're going to submit to the professor, if it could not be approved by your circle of friends, it cannot be submitted to your professor. Your friends who are your proofreaders have to approve it. And what's the best kind of proofreading partner? It's the kind of person that'll look at you and say, you know, what were you smoking when you typed this? Yeah, they got to be able to tell you that you're absolutely nuts. And so find people that will tell you the truth about something. Yes?
On basic, it says basic colorization.
Oh my gosh, y'all are deadly today. Y'all can tell I did this on the weekend. All right. Yeah, I make lots of mistakes.
Mostly the reason why relatives is proofreading really matters when it comes to BEA.
I am scared to death to show y'all this last page. This last page is nothing but a table that you probably will never ever need the rest of your life. I'm simply trying to show you that whenever you say the name of the base, that you're saying how many counting values there are. Look at column 1. It's called a radix. The word radix is one of those names that, yes, that is the real name for this. But are you ever going to need to know it this side of getting a PhD? No, you're not. What does radix mean? Radix simply means the number of counting values. So a lot of people say that when you say the base of a number, that you're also saying the radix, as if they're the same thing. And they really are. Because when you say the name of the base, like base 8, you've got 8 counting values. What is the radix of base 8? 8. It's the number of counting values. So notice I numbered that last column in the left. I numbered it all the way from 1 to 16. So you ought to simply see how many counting values there are. We've already looked at base 16, starting at 0. We go all the way from 0. We go all the way from 0 up to 9, and then A, B, C, D, E, F. And that's how we come up with 16 counting values for base 16. We have to add letters to those. Base 10, we start at 0, we go to 9, and that's a total of 10. Base 8 has 8 counting values. You can just draw a line from the zeros over here and see that there are 8 counting values in base 8, and the largest of those will always be 1 less than the name of the base. Base 2 is the same thing. Okay, so we got 2 minutes left, and tomorrow I'm going to actually walk you through a base 2 conversion. See ya.